So hi guys, in today's video we will be discussing a problem whose name is best time to buy and sell the stock. It is a very famous problem and is generally asked in a lot of coding interviews. So let's see the problem. You are given basically an array of prices where prices of I is the price of a given stock on particular ith day. So basically we are given an array, uh, the each index where represents a particular day, like first index represents okay it is the first day, third index represents it is the third day, and fourth days, and so on. So a value on that particular index, for example value on the second index, is a price of a particular stock on that particular day. So it is clear, and then we are required to choose 2 days, basically one day to buy a stock and the other day to sell the stock. And obviously we have the condition is we have to sell the stock in future only. So by these things we have to find the maximum profit that is achievable, and that too in this particular one transaction. So this problem has other similar problems also, where the variations are like only two transactions are allowed, k transactions are allowed, and infinite transactions are allowed. So these problems are almost similar to one another. So let's understand some test cases what they try to mean. So here it is given first test case. So basically the indices are like 1, 2, 3, 4, 5, and 6. So basically these indices represent a particular day, like third day, fourth day, fifth day, sixth day. And the value at this, like on the first day the value is 7. So 7 is the price of that stock. So the question says that we have to choose 2 days. Okay, the first day we have to choose is when we can buy. Okay, randomly I chose this day to buy. Okay, I bought on this day, I bought it for 5. Now I am required to select other day where I have to sell the stock. Okay, if I select this day and if I sell the stock, so my basically profit will be -2, which is obviously I am in debt. I will not sell on this day. Rather, I will choose to buy on the same day and sell it on the same day. So, what other thing I can do? If I bought on third day, I will try. Okay, I can sell it on fifth day. Then my profit will be 1. Okay, now I am in positive. So basically, this can contribute to my answer. And if I similarly I cannot sell the same stock on sixth day, so that's the case. So if the main thing we observe here is like if you are given like you have to buy on this particular day only, then what is the best you can do to gain profit? You will obviously look to the right of all the days and select a particular day. Which particular day? The day where the price of that stock is maximum and is obviously greater than the day it was bought on. So obviously it will be 6. So if here if you buy on fourth day, the maximum profit that is achievable will be 3. But we are given that we can buy on any day. So we have to explore all the options and check what all options can contribute to our answer. So I will take another test case like in this example. If I know, okay, this is decreasing array. So let's perform on this only. Like if I buy on this day, what can I where on which days can I sell? I can sell on this, but what will be the what day will provide me the maximum profit? Obviously this day, because on the if I travel to the right of it, then this day will come out to be the day where the price of that stock is maximum. Basically what will we will try to do is, like we will select every index, and if this index is selected, then I will iterate over all the next indices and find out which is the maximum that can contribute to this person. For example, if on this day the stock is bought, similarly on if on this day the stock is bought, if on this day the stock is bought, so like this we will be basically building up our answer. So let's see, let's try to code it. So basically first we will initialize size with prices dot length, and we will keep a variable answer which will be storing our answer. So the one key point is that we have to initialize our answer with 0, as obviously the minimum answer that is possible is 0, because in the worst case scenario, for example in this case only, like it is decreasing array. So obviously if you buy on any day, you won't be able to find a day after this day where the price is greater than this particular day, so you will choose to buy it on this day and sell it on the same day. So the answer will be basically 0. So that is the reason we have initialized the answer variable to 0. Okay, so we will be iterating over each index each day basically, and then we will uh, then for that particular day we have to iterate over all the next days. Like again I'll explain, like if on this day the stock is bought, then I have to iterate over next all days to find out the maximum. So basically from j from that particular day to the last day. Now I will what I will be doing is I have to store my answer, which will be maximum of the all previous answers that I have stored in it. And now what I will be doing is prices of j minus prices of I. So I will explain this, like I is this one if you are standing on this particular day, and if you are iterating one time j will be this, then again this. So basically it is difference of these two. So this is enough, and we can return our answer. So let's see if it is working. Yes, it is working correctly. So let's try to submit it. So it is giving time limit exceeded. So let's see the constraints if they are given. Yes, the constraints are given. So it says that the length of the array is basically 10 to the power 5. So since we know that if the time limit provided is only 1 second, then at max we can perform 10 to the power 9 operations. But if we analyze the complexity, so basically two for loops, and that too both running till n. So basically the time complexity is n square. So in the worst case, this the operations will be 10 to the power 10, since the length of the array given is 10 to the power 5. So what else can we do to optimize our answer? So or can we really optimize it? So how can we think of it? So the main idea, that is the main thing which is basically increasing the time complexity, is that we have to iterate over all the next indices and find which is the maximum for this particular person after its index. So what can we do? Let's try to see this. We can like start to iterate from last index and store, like for if I start from this index, the maximum for this particular index will be a person next to it, or like 4 itself. So for this the answer will be 4 itself. Now if I am on this index, what will be maximum on the right and itself for this index? So basically 4 is less than it, and 6 itself. So basically 6 itself will be the maximum for its. And if I am at 3, now I will check, okay, is 3 itself greater than the next possible, basically which is the 6? No, obviously it is not. So 6 will carry on. This 6 is representing the maximum up till all the next indices. So obviously we don't need to iterate over all the forward indices. We have to just check next index. So like similarly for this 5, is 5 versus 6, which is greater? It is obviously 6. And for 1 it is again 6, but here for 7 it is 7. So we have like stored this in an array. This can really help us if we see. Okay, so now the same for loop, if we apply for each index, like I started from 7. Okay, now I need the maximum for 7 on the right of it. So we already have it, which is 7. So maximum profit that is achievable if I buy a stock on this particular day is 7 minus 7, which is 0. Now again, for if I am on if I buy on this particular day, so what is the maximum profit achievable? It is obviously the maximum to the right, which is 6 minus this particular one, so it will be 5. Similarly for this, maximum to the right of 5, which is obviously stored, so the answer will be 6 minus 5, which is 1. Similarly for this, 6 minus 3, which is 3. And if we keep on going like 0 and 0, and if we find that yes, the maximum among all these values that we iterated over, so basically it is 5. So if we see, yes, it is our answer. It is our answer. So we are good to go with the approach, but now we have to figure out how to store this max. So let's make a DP array. Now its task will be to basically store the next maximum up till that particular index. So we will be starting from end of the array and traversing backwards. Now if now here it is something important, like if I is equal to n minus 1, if it is the last index, if it is the last index, then maximum for it will be itself only. So this is the base condition of a DP, and here we will be initializing it with prices of I. Else what will be the case? DP of I is equal to math dot max of DP of I plus 1 and the value itself. So I'll try to explain it here. So basically it is like for this index, like for this index, now the maximum will be either this 6, basically, which is I plus 1, or this 3 itself, so which is basically 6. So we will store 6 here. So this is what we are doing. And now after this for loop we have all the indices stored in uh, sorry, indices, not indices, maximum values stored in DP array. So our task is really simple now. Now we have to do just one for loop, and that too the maximum of basically DP of I minus prices of I. This is because if this is the maximum of all forward days, and this is if I buy it on this particular day. So basically this will store my answer in ANS variable. So let's try to run it and see if we are right. So let's try to submit it. Yes, so the solution is submitted. Let's analyze the time and space complexity. Now if we analyze a time complexity here, so basically the time required was, we just iterated the array once from end to store the maximum. Basically it will be O of n, and the space required, and we made a DP array extra to store all the max. So basically the space complexity is also O of n. So but here is something better we can do. For the space we can just do it in O of 1. Why do we need to like store every index for every index? So let's see that approach. So I will be commenting this. I will make a variable named max, which will be storing maximum to all the right indices. Basically I will initialize it with 0. And now what will I do here? I will start my for loop, and I will start reversing it from backward. And now I will update my max with what? With maximum of already existing value in the max versus the index itself. So here our max is updated. Now we have to do the same step. We have to store our answer, and now the same thing, max minus prices of I. So let's try to give it a run. Yes, it is running fine. So yes, basically the time has also increased because it takes somewhat more time to retrieve from array, basically, which is memory, which is stored as memory in the memory. So yes, that is it. We can analyze the time complexity again. Basically, time complexity will be O of n and space will be O of 1. So that is it for this video. Let's meet in the next video. So like, share and subscribe, and do comment below if you like. Thank you.